So today we're going to talk about exponent rules, and hopefully that this is just a refresher to your memory. But for some of you, you might think that you haven't done any of these rules since you took Algebra 1, which probably isn't true, but it might seem like that long ago. And first of all, we've got a to the m times a to the n. When we have like bases, what do we do to the exponents? You remember? You actually add them. It's a to the m plus n. Notice, we didn't multiply a times a and then do the m plus n. We kept the a like it was, and we added the exponents. And it's the same kind of idea when we get to rule number 2. A to the m times a to the n. When we multiply, we add exponents. So the inverse operation of multiplication is division. So what do you think we do to the exponents? Well, we subtract. A to the m divided by a to the n is a to the m minus n. This is when we have like bases, when the value for a is the same on the top and the bottom. Number 3, a to the 0. Do you know what it equals? It equals 1. A to the m raised to the n is what I call sometimes the superpower rule. And what happens is, this is the one where we multiply those two together, and we get a to the mn. And these other two after it are along the same lines. But what happens is, what's inside the parentheses gets raised to what's outside the parentheses. So on number 5, which is number 4 on your paper, it's a to the n, and then it's b to the n. What's inside the parentheses gets raised to what's outside the parentheses. And finally here on number 6, which is number 5 on your paper, even if it's a fraction, what's inside the parentheses gets raised to what's outside the parentheses. So this becomes a to the n divided by b to the n. So as we move into the examples here, I'm going to do probably about 5 of them, and then come back later and do some more if we have time. I want to get the basics at least, and I want to get through all of the rules. So the first one here, we're going to simplify, writing our final answer with positive exponents only. First one, x cubed times x to the 4th. Remember, when we multiply, that goes back to our very first rule, and our very first rule then says that we would add the exponents. No, you don't necessarily need to write that step. What is x to the 7? Just as in the side, x cubed is x times x times x, and x to the 4th is x times x times x times x. And how many total x's do we have? Well, if we count 1, 2, 3, 4, 5, 6, 7. That's kind of where it comes from, and especially if you get in a testing situation and you panic and you forget, you can kind of go back and figure it out. But once again, when we multiply two terms with like bases together, we add the exponents. When we're dividing 2 with like bases, we subtract the exponents. So this becomes x to the 10 minus 2. Well, 10 minus 2 is 8. And then when we simplify this here, and again, you don't have to write this down, 3, 4, 5, 6, 7, 8, 9, 10. Divided by that, what's happening is this one cancels out and that one cancels out. And how many do we have left? 1, 2, 3, 4, 5, 6, 7, 8. Just a little bit of an aside, something that we talk about in Algebra 2 that you may have forgotten, and I won't spend too much more time doing that kind of thing. But again, in a panic time, that's something that you could use to help you figure out what the rule is if you needed to. Number 3, x squared times y to the 5th, all cubed. What's inside the parentheses gets raised to what's outside the parentheses. So in this particular case, what we're going to do is we're going to take x squared, and we're going to cube it. We're going to take y to the 5th, and then we're going to cube it. And when we have an exponent raised to another exponent, that's when I start talking about superpower. And all that superpower means is that we need to multiply those exponents. So x squared cubed is x to the 6th, 2 times 3. Y to the 5th cubed is y to the 5 times 3, which is 15. Number 4. Same kind of idea here, but now we actually put numbers in it. But once again, what's inside the parentheses gets raised to the power outside the parentheses. So this one becomes 3 squared x squared and 4 squared. If you need some work, some people don't need to even show that work. Another way to think about this is that this is 3x over 4 times 3x over 4, because squared means times itself. But either way, when we simplify, 3 squared is 9. It's 3 times 3. If you do want to look at it from the superpower, here it's x to the 1st squared, which is x squared. And 4 squared is 16, which is the same value that you would get with those blue values. 3 times 3 is 9. X times x is x squared. On the bottom, 4 times 4 is 16. One more here of the basic rules. Number 5. Negative 6x to the 0. The thing that you need to realize about this problem here, first of all, is that the answer is negative 6. Now, where am I getting negative 6? And some of you are thinking, well, the answer is 1. But this is negative 6 times x to the 0. And x to the 0 is where we're getting that value of 1. So negative 6 times 1 is negative 6. Don't confuse it with this. The 0, the x to the 0. The 0 only applies to the x the way the problem's written. If the problem were written as negative 6x with parentheses to the 0, then that 0 would apply to every thing being the negative 6 and the x. Negative 6x to the 0 is what equals 1. But because there's no parentheses in here, the 0 only applies to the x on that problem. Again, maybe come back and look at 6, 7, and 8 in a couple minutes. Section 3. A few more exponent rules. And actually, these are the ones that probably caused the most trouble. You probably remembered those first 6, or mostly. But then when we get to the negative exponents, first of all, negative exponents doesn't turn the problem into a negative. And that's usually the biggest flaw that I see. But what a negative exponent does is, the way I like to explain it is that we flip the term and change the sign of the exponent. So a to the negative n is really 1 divided by a to the n. And what I mean by flipping it, we could put this a to the negative n over 1, then we flipped it, so we took the reciprocal, and we changed the sign on the exponent. And it's the same here on number 8, the negative exponent's in the bottom of the fraction this time, but we can still flip this so it becomes a over 1, and then we change the sign on the exponent, and no, we don't need to write the 1. So 1 over a to the negative n is just a to the n. And over here, with respect to the fraction, a to the negative n over b to the negative n, we can flip this. So b and a change places. We flipped it, and then we change the sign on the exponent. Notice, I did not turn anything into a negative number or a negative variable. What the negative exponent does is it changes something to a fraction, or it gets rid of the fraction, or it flips the fraction. The other thing is that sometimes I say, if you cross the line, you change the sign. So we cross the line, we change the sign. So x to the negative 4. Again, we want to simplify. We want to write our final answer with positive exponents only. The only thing that we can do in problem number 1 is we can flip this and change the sign on the exponent. That's it. Same kind of idea here in problem number 2. We have a negative exponent. We're going to flip this and change the sign on the exponent. If you want to, you can leave the 1 in the denominator. You do not have to. We flipped and we change the sign on the exponent. The problem 3 here takes into account a couple of rules. And the way I read it, and it might not necessarily be the same way that you read it, is I see this as a division problem. X to the negative 3 divided by x to the 7. Well, what do we do to exponents when we divide? We subtract. So when we look at this problem, one way to do this is to say, well, this is the same thing as saying x to the 3 minus 7. Because when we divide, we subtract exponents. I subtracted the bottom exponent from the top exponent. Well, that gives us x to the negative 10 when we combine those. But we want to write our final answer with positive exponents. We have negative exponent. All that we need to do to finish is we need to flip and change the sign on the exponent. So it becomes 1 over x to the 10th. Not the only way to do that problem. I hope it's an easy way to do the problem, but it's not the only way. I'm going to do problem number 5 and come back to problem number 4. Two x squared divided by 3 raised to the negative 2nd power. Once again, negative exponents. We're going to flip. So this is going to become 3 over 2x squared. I'm not changing anything on that fraction. We flipped it. What changes is that negative 2 becomes positive 2. That's what changes. Flip and change the sign on the exponent. Now that we've taken care of the negative exponents, what we need to do to finish this is what's inside the parentheses gets raised to what's outside the parentheses, and it looks fairly familiar in terms of problems. It's not the same exact one, but this is going to be 3 squared divided by 2 squared and x squared squared. I like to put parentheses around the numbers because if those numbers did happen to be negative and you typed them in your calculator, you would want parentheses. But 3 squared regardless of with parentheses or not, is 9. 3 times 3. And 2 squared, whether there's parentheses in the problem or not, is 2 times 2, which is 4. And x squared is x to the 4th power. We superpower that. But still looking at the negative exponents, and these are the ones that cause us the most trouble. Let's flip our paper back over to number 4. And once again, we can deal with the negative exponent. And what we have to do is we have to flip and change the sign of the exponent. We've got a negative exponent outside of the parentheses, so that negative exponent applies to every part inside the parentheses. So this can be 1 over 5x squared y to the negative 4. I didn't change anything there. I moved it because we're going to cross the line and we're going to change the sign on the exponent. We flipped and we changed the sign on the exponent. That applies to the entire problem. Well, once we get it in the right format, then once again, what that means is what's inside the parentheses gets raised to what's outside the parentheses. So this is 1, and then this is going to be 5 squared. And x squared squared. And y to the negative 4th squared. So we simplify. 5 squared means 5 times 5, which is 25. X squared squared, there's our superpower. 2 times 2 is 4. I'm going to superpower with the y's also. So negative 4 times 2 is negative 8. But once again on the directions, write your final answer with positive exponents. We're not going to touch 25. We're not going to touch x to the 4th. But we have y to the negative 8. We need to deal with that one. And what we're going to do is, in particular, we're going to flip that part and change the sign on the exponent. So when we flip, once again, the 25, it's not moving. The x to the 4th, it's not moving. The y to the negative 8, we're going to flip and change the sign on the exponent. And if you prefer, you can leave a 1 there as well. The negative exponents, they change where the value was located. If it's a negative exponent in the bottom, you move it to the top of the fraction. If you have a negative exponent in the top of the fraction, then you're going to put it in the bottom of the fraction. So we'll flip our paper back over. Let's look at number 6. We've got 9x squared to the negative 2nd times negative 3xy squared cubed. Well, let's deal with the negative exponent. The negative exponent says that we're going to flip. We're going to change the sign on the exponent. So once again, I'll point out that the negative 2 becomes the 2. We flipped and we'll change the sign on that exponent. Over here, in this second part, we can start simplifying. This is going to be negative 3 cubed and x cubed and y squared cubed. And because we're going to have to multiply here in a couple minutes, we multiply the tops of the fraction and we multiply the bottoms of the fraction. I'm just going to write this over 1. But we did that with the second part, where we took what's inside the parentheses and we raised it to what's outside the parentheses. We need to do that same idea here with the green part of our problem, this is going to be 9 squared, and then it's going to be x squared squared. And we can get a little farther over here in the orange part, because negative 3 cubed, and again, if you're typing that into your calculator, you're probably better off with parentheses, is negative 27. And x cubed, it's x to the first cubed if you want a superpower. And y squared cubed is a definite superpower. Y to the 2 times 3, which is y to the 6, over 1. We need to go back to the green and we need to simplify it. And this is going to be 1. 9 squared is 9 times 9, which is 81. And x squared squared is x to the 4th when we superpower. And now we're close. Negative 27, x cubed, y to the 6, over 1. When we multiply the tops of the fractions together, and we multiply the bottoms of the fractions together. So what we end up with is negative 27 x cubed y to the 6th on top, because we multiplied that by 1. And in the bottom we have 81 x to the 4th. And we're not done. Because what we need to do now is we need to simplify. And the nice part is your calculator will do this for you. If you go to alpha y equals, if you have the fraction button on your calculator, and you do negative 27 divided by 81, it will simplify the numbers there for you. So negative 27 divided by 81 is negative 1/3. But we also need to simplify the x's. And for me, I'm just going to take this and say that this is going to be x cubed, x to the 3, minus 4. We're dividing the x's here. And then we still have this y to the 6th up on top. So we're almost done with this problem. But we need to simplify on that x. We can't do anything else to the numbers. The negative 1/3, it's done. And the y to the 6th is actually done as well, because it has a positive exponent. What we have still is the negative 1/3, but now we have x to the 3 minus 4, which is x to the negative 1. So we subtracted. X to the 3 minus 4 is x to the negative 1. Again, the y to the 6th, it was finished. So our last step now is to deal with that negative exponent on the x. And what we're going to get is we're going to get negative 1/3. We're going to flip and change the sign on the exponent. And the y to the 6th is not going to move. The only part that moves is the value that has the negative exponent. One more exponent rule. When I have 2 blanks, that's why I put 1 in quotation marks. But we can have an exponent that's a fraction exponent. And when we have a fraction exponent, what it does is it converts the problem back into a radical format. So what happens then is that this a to the 1 over n becomes the nth root of a. A goes underneath the radical. I sometimes do use the word radicand, which is what it's called. The value from the denominator of the fraction goes in the check mark part of that radical. And if you want to get technical, this is a to the first. But a to the first is still a. So we don't really need to write that 1. But I'll try to write it a little bit neater over here. There's when it's 1 over some number, but it could just be a straight fraction. And a to the m over n, we can do the same thing. The a is going to go underneath the radical symbol. The n is going to go in the check mark part of the radical. There's where the n goes, in the check mark part. Hopefully you see what I mean by check mark part. It's actually called an index. And the m is an exponent on the a. But I put an or in there because if you're using a calculator, that first definition is fine. But if you're not using a calculator, it's still a and it's still n in the check mark part. But we can raise it to the m outside of there. And that second way, at least for me personally, I can do that without a calculator, which is why I choose to use that one. But it doesn't make any difference to me. But if you look here at part A, it says sometimes fractional exponents are used to represent powers of numbers or variables. The numerator of the fraction, m, represents the power. See how it's a power? And the denominator, n, represents the root. So we're taking the nth root of a in all 3 of those blanks. The exponent in the denominator has to be positive. Well, let's practice this because this is new, to the best of my knowledge, to most of you. And we've got x to the 1/3. And all that we want to do is we want to rewrite this so that it's in a radical form. All that means is the x is going to be the radicand. It's the number, or the variable in this case, underneath the radical. And the 3 is going to go in the check mark part, because it's the denominator of the fraction exponent. And if you want to get technical, you can put the 1 right there. We need to be able to convert it. Over here, number 2, x to the 2/5. X is still going to go underneath the radical. Denominator is going to go in the check mark part of the radical. And the numerator can go here. Or if you prefer, the 5 is still going to go in the check mark. The x is still going to go underneath. But we can put the 2 outside. Number 3, x to the negative 2/3. What do we do with the negative exponent? We flip. Change the sign on the exponent. So this is going to become 1 over x to the 2/3. We flipped and we change the sign on the exponent. And then we can rewrite this as 1 over, well, the x is still the radicand, the value underneath the radical. The 3 goes in the check mark part of the radical. And then the 2 there is probably the easiest way to write that. We could put the 2 outside in the parentheses, but it's probably easiest just to write it in the format that it is. The thing is, there's going with a fraction exponent to a radical. We can also go the other direction here from a radical to a fraction exponent. But the one thing that we need to know is, what is the number in the check mark part of the radical when it's not written? Think about how we describe this. This is the square root of 10. So what we're looking at is square. How do we write square? We write it with a 2. So if it's just square root, it's understood that that's a 2 in this problem. And once we know that, then this is going to be 10. Remember, the number in the check mark goes in the denominator, and it doesn't have any exponent on the 10, so it must be a 1. 10 to the 1/2 is the square root of 10. Number 5. Same thing here. Now we know there's no number written in the check mark part, so this must be x, the 2, no number written in the check mark part means that it's 2, square root of x to the 9. And then we can put the 9. Number 6, which is the cubed root of x to the 6. Once again, the number in the check mark part, and by the way, it wasn't written on number 5 as a 2, but number 6 it's written. That's our denominator. And then we have a 6 for the numerator. And by the way, we can simplify that. X to the 6 over 3 is x squared. But to finish, I realize that you can type this in your calculator. But the question is, can you do it without typing it in your calculator? And I'm not going to take the calculator away from you on this. Can you rewrite this as a radical and figure out the value? Like 144 to the 1/2 power. The 144 is going to go underneath. We don't need to write the 2. Because to the 1/2 power means square root. Do you know what the square root of 144 is? And hopefully you're at least thinking 12. Number 8. Once again, if you write it as a radical, the base becomes the radicand. The denominator becomes the index. That's the number that's in the check mark part of the radical. The 4 through to 16, it means what number times itself 4 times gives you 16. It's 2. A little bit more complicated here on number 9, but not too much so. Write it as a radical. The base is the radicand. The denominator is the index. And then I'm going to write it with parentheses so that we don't need to use a calculator. But it's the cubed root of 8. So what number times itself 3 times gives you 8? 2 again. And then we square it. And 2 squared is 4. And finally, 32 to the 2/5. Base is the radicand. Denominator goes in the check mark part of the radical. 5th root of 32. What number times itself 5 times gives you 32? I got stuck on the number 2 there. The 5th root of 32 is 2, and then when we square it, we get 4 again.